All right, so if you remember, right, about a week and a few days ago, we looked at normal distribution. And we kind of explained what normal distribution is. We talked about how important it is. We said that it's the most popular type of continuous probability. And we said one of the reasons why it is such an important concept is because it's used in almost every facet of our lives, right? And you guys even did the discussion about normal distribution. And we moved from there to look at, then we moved to look at critical limit theorem, right? So we did sampling distribution and then critical limit theorem. And that will take us into a new topic called confidence interval. And I wanted to use a simple example to kind of explain what confidence interval, that's why I have all those numbers there. So before we even go any further, what confidence interval does is something unique. The two words in that whole sentence is important: confidence and interval. The concept of confidence interval is as such. You have a population, right? You want to find out about that population. You want to find out what we call the population parameter. If you remember, right, when we met in week 1, we kind of explained what parameter is, right? We said it's any numerical value that helps to describe a population. For example, a mean, right? So let's say you want to find out the average age of business students, right? What is the mean age of business students? Well, let's assume that PC does not publish or does not ask students to submit their age. So we don't know, right? So this is completely unknown to us. So what we can do is, and this is where confidence interval comes in. What we'll do is we now sample, right, a few students. So let's say, for example, now say, okay, let's get a sample of 100 students, right? So n will now be 100, right? And so once we get a sample of 100 students, we'll now say, let's ask them what their age is, right? And let's see that after 100 students, they told us their age. So the sample mean is now, let's say, 34, right? Now remember, right, that this is a sample from the population, right? This sample mean is also known as the point estimate, right? So now, once we sample this, right, we now found out that the average age of the business students was about 34, right? That's what we found out to be. Now, we have to always make room for errors, right? There's always going to be a chance that we might make a mistake, or in fact, the very fact that we are using only 100 people. Remember, PCC has about 30,000 students. Just the singular fact that we're using 100 people to try to tell us about 30,000 people, right? There's going to be room for some error. And so we're going to have what we call a margin of error, right? A certain percent of our work that might have mistakes, right? And so that is known as our E, or also known as our margin of error, right? And so what we do in this topic is basically we now say, okay, this is what this mean is. To be able to find what the real average age of students is at PCC, we have to look at our sample mean and also look at the error that we can have and make room for that error. And so we'll now say the sample mean, which is this that we have from 100 students, we'll now say plus minus what? That error, right? And so what we've done here is we've created a range. So let's say, for example, right, the error was 5 years, right? So what we have now, it's going to be 34 years plus or minus what? 5 years, right? because we're trying to find out what the real age of PCC students is, right? And so on the lower level, right, it would be 34 minus 5, which is 29, right? In the upper level, it would be 34 plus 5, which is what? 39, right? So now we're now going to ask ourselves, how confident are we with the true population of students at PCC is between what? 29 and what? 39, right? And so we can say we're 80% confident, we're 90% confident, we are 70% confident. Whatever level of confidence, right, we use that to calculate that. So what confidence interval, in essence, what it does is it checks to see how confident we are that this range we've created, also known as what? Confidence interval, really contains the true age of the average PCC student. That's what this entire topic is about. Any questions on this? Kind of wanted to give you a short explanation of this before we go into looking at in depth. So at the core, what we do is we want to find out what the population parameter is. So for example, population mean is. We can't find it because we're not given. And so the best way to do is what we call inferential, right? Make an inference. Say, oh, okay, based on, we're going to pull up some sample, and then we're going to check on that sample, right? And so we did that, and we got 34 years. So we now say there's going to be a chance that we'll make some error. And so we deduce our error. The formula for error is actually the z value times standard deviation over what? The square root of n. Can anyone tell us what this is? Can anyone tell me what this formula is? Anyone? Standard deviation over the square root of n. Samuel, what's that formula?
I'm not sure, Professor.
You what?
I'm not sure.
Okay, that's fair. This is the formula for standard error that we did last week. And so doing that, right, can help us tell us if our interval, right, really contains our population mean. That's the whole essence of this topic, right? Now, there are two ways we solve questions involving confidence interval. There's a way we can solve it if the values are 30 or more. So when our sample is 30 or more, we use z values to solve it, which you are already used to in this class on what z values is. Now, if it's less than 30, we solve using what we call t-distribution. And I'll explain that in more detail when we come to class on Wednesday, right? So today we're going to solve for values 30 or more. So we're going to use z values that you're used to. When we come to class on Wednesday, we'll solve similar questions, but slight difference. Here we'll have numbers that are less than 30, right? And so we'll use t-distribution to solve that. Okay. So kind of explaining some of the concepts, right? You can see here, I said, this is an example of a sample mean, right? And so a point estimate is a single estimate value that estimates for what? Population parameter. The most unbiased point estimate of a population mean is what? Sample mean, right? So sample mean is the same thing as a point estimate. So when you see them, various textbooks, sometimes they mix them up. If you see that mix up in the textbook, don't get confused that it's a different concept. No, the sample mean is the best example of a point estimate. All right. So remember, we said that after you created your confidence interval, right? You can try to see how confident you are that that interval you created actually has the population mean, right? For example, the one we did in class was 29 years and 39, right? And we wanted to see how confident we are that this contains the true population mean of PCC students, right? That values level of confidence, right? If it's 80%, or if it's 90%, or if it's 85%, it's denoted by a small c, right? That stands for our level of confidence. And our level of confidence actually changes as we draw closer to a plausible number, to a possible value, right? And once we get further away, we are more confident. As we get closer to a possible value, we become less confident, right? If we're in the classroom, what I usually do is I'll give an example of basketball, right? If you have a bigger arena, right, or you have a smaller arena, how you are going to get a ball to go through, right, will be when you're trying to shoot hoops, it's going to be different compared to if you have a smaller one. But I'll use an example here. I'll use myself as an example to show you how level of confidence works, right? And you're going to see that your answers here will show clearly that when we get closer to those values, right, our level of confidence changes. So I'm going to use myself as an example here. And then from there, we'll move on to look at margin of error and the rest. Okay, so what I want to do here is ask you to tell me, I'll use myself as an example, right? So what I need you to tell me is using percentage. You tell me how confident you are that my age falls within these categories, right? So I'm going to ask you this. How confident are you that my age falls between 10 and 100? Anyone?
100%.
100%. Okay. All right. How about 20 and 90? Anyone?
100%.
100%. Okay. Thank you. That means I'm clearly less than 90 years old. I feel honored. How about 30 and 60?
100%.
Okay. Okay. Wow. So I'm less than 60 years old. Now, boy, do I feel young. All right. How about 35 and 45?
100.
100%. Wow. Okay. All right. How about between 20 and 30?
75.
25. Okay, now you're just joking, right? He's trying to get extra credits. He thinks he will get extra credit. What is this if it's nice to me? But what I wanted you to show is to see is you definitely know that I'm between this age, right? And so you were 100% confident. Once we got here, right, you still were 100% confident. Huh? When we got here, right, you paused a little bit, right? Even though you said 100%, I'm sure you paused to think a little bit, right? You didn't just snap out and say, that's true. Because there's a possibility that I'm above 60 and I just use very nice moisturizers, right? And so that's it. And you haven't seen me, many of you haven't seen me face to face, so you don't know if I'm using, Zoom to kind of create a false image, right? So you couldn't do that. When it got to 35 and 45, you paused and thought more. Why? Because as the range gets smaller, right, your level of confidence reduces. Here you felt more comfortable because it was obvious that was right. But once you got to these numbers, this one and then this one, you have to rethink. And you say, it's possible that this guy is over 45. It's possible, right? And then when we got this one, right, you knew very well that this is almost unlikely. So your most choice here will be either 5% or even minus 5% if it's possible, right? Because you know that there's no way that he's less than 30 years old. So, but this is where it was very important to see, because what had happened is that you were not sure. And once you were unsure, your level of confidence did what? Reduce. And that's what happens even here. When you're doing confidence interval, right? When you have high confidence, usually your level of your confidence interval is bigger. Once your confidence interval gets smaller, right, you begin to have less confidence, because guess what? The numbers are you can't play around anymore because the numbers are so close to one another, right? If I say, what about if I'm between 42 and 44 or 43 and 47, that even gets more difficult, right? Because here you have 10 numbers to play with. But if I bring it to 36 and 39 or 42 and 45, then it becomes even more difficult. And you're going to say, oh, maybe 45, maybe 25%. And that's a key thing to understand when you're solving confidence interval, right? All right. All right. So we say that the level of confidence, right, which is C, right? This is how confident your level of confidence is a probability that the interval estimate contains what? The population parameter, right? The level of confidence is the percent of the area. So pay attention here. The level of confidence, which is the small c, is the percent of the area under the normal curve. So basically what happens, the level of confidence is usually in this manner. And so you have the z value, minus z value, and then you have z value, right? So usually, right, the value that you have here stands for your whatever level of confidence you have here, right? So if I want to know the level of confidence here, if I find my z value here, that would tell me what the value is, right? And usually, right, the value of z here and the value of z here will actually be equal. The only difference is that here will be negative and here will be what? Positive, right? But that is the value that denotes that z level of confidence. So this is 90%, right? This is 90% because we're dealing with a symmetrical curve, right? So if this is 90%, that means here will be what? Anyone? What will be the value here?
2, 5, and 5.
5, thank you, 5 and 5, right? And so this is our level of confidence. This place is where we're not confident. It is denoted by what? Alpha. So anytime you see level of confidence to be, let's say 90%, that means that the level that we're not confident, which is our alpha, will be what? 1 minus what? 90%, and that's going to be what? 10%. Right? And so our level of confidence will plus our alpha gives us what? 100%. Right? So if our level of confidence here is 90%, then for us to be able to find our alpha, it will be 1 minus that value. And since it's equal, then it will be 5% this side and what? 5% this side. Right? All right. Any questions so far? All right. Okay. Now our margin of error. So like I said, right, to find our confidence interval, right, is basically our sample mean plus minus what? Our margin of error. Now margin of error is basically our z value times standard deviation over what? The square root of n. Right. Questions? Let's keep going. If there's any question, you can always stop and ask. Now, Now, usually, right, to find our level of confidence, right, we can find, if I give it 80%, so 80% here, the Z value is 1.28, right? And the Z value is just, remember, it's alpha divided by 2, right? It will give you for those two sides. So 1.28 for 90% is 1.645, for 95% is 1.96. But I will also show you how to do it in Excel, so you don't have to worry about cramming this stuff. In the exam, you can feel free to use it, but I usually show you how to do it in Excel, so you don't have to look for this, right? Just stop that. Okay. So, like I said, right, this is the formula, right? Your sample mean plus or minus what? A margin of error right here. And this is actually a good graph to show you this. I'm going to do it in Excel anyway, but I want to show you this a good graph. This is an example of a 95% interval, right? So this is 95% or 0.95. So you can see that if it's 0.95, so what you have here is 0.05. Divided by 2 is 0.025, and then 0.025, right? So this part, this gray part, and this gray part, those are the parts where we don't know. We're not confident. This whole part is where we're confident, 95%, right? And it's divided straight in the middle, right? Okay. We're going to come back to this when we solve questions. We're going to come back to this graph so that you understand what this graph means when we solve scenarios in this area. All right. Now, the next thing that we may be asked sometimes is to also find what we call our sample size. So how does that work? Well, remember, confidence interval requires you to solve questions sometimes and to find out how confident you are that you can get that the population mean is within any given interval. Let's say, for example, you want to find out the average age of business students, but you want to be 95% confident. So if you want to be 95% confident, then what sample size does is it will tell you how many people you need to talk to get 95% confident, right? The formula will tell you, so N is equal to your Z value times standard deviation over what? E squared. What that means is if I want to be 95% confident that the interval I will create will contain the average age of business students, then I will need to use this formula, and this formula will tell me how many students I need to interview to be able to get that 95% confidence. So it's like the other way around, right? This time around, I want to get to 95% confidence. So to do that, I have to talk to this amount of students, because if I talk to that many students, then I'm guaranteed to get a result that is about 95% confidence. Obviously, if I want to get to 95 compared to 90, I'll have more numbers, right, for 95, because the more people I talk to, the more confident my result will be. And that's why even in things like in polls, right, when you listen to polls, right, they will say, oh, we interviewed so people and we got this result, right? And this is a good example to use. Poll results are one of the best examples to use to do confidence interval. So imagine if you look at the news, right, or you look at any newspaper, right, you see poll results for anything, for like sugar content, for how many people who like this more, or there's always different polls, right? Some polls are like to find out how many people like the president, or how many people like to eat sugar. I mean, what? So many of them, right? Let's do, for example, that we want to find what percent of Americans like. Let's find something common, right? Diana, what's your favorite snack?
Hot Cheetos.
Okay. Did I spell it correctly?
Yeah.
Okay, cool. I was almost sure I would get it wrong. Okay, so let's say yes and no, right? So let's say, for example, that we decide to ask students in a school to find out, right? And let's say, for example, they say we get like 60%, then we get 40% don't like it, right? And I know you're thinking, how would someone hate this stuff? So if we get that result, right, usually at any of these results, right, you look on the right, there's always a sign, just fine print, right? It will say margin of error plus or minus what? Let's say 5%, right? What they're saying here is that there's a chance that there may be some errors. There may be somebody who says they like hot Cheetos, but they don't like it, but they're saying that because, for example, let's say that my wife likes hot Cheetos, right? And I don't want to upset her, so I say, yes, I like it too, right? So I'm influenced by her, right? Or let's say, for example, there's somebody who is going to offer me a free one if I say I like it, so I'll say that, right? Or let's say, for example, I just didn't even check, I just chose one and walked away. There's going to be a lot of people, right, who are going to make choices based on various scenarios. There's also going to be mistake in handling the results, right? Maybe somebody said no, but when I was collecting it from them, the ink spread on yes, or the ink spread across yes and no, and I had to think of maybe they wanted yes or no, right? So there's always room for those errors, right? And so most statisticians will always have margin of error, right? That is to denote any mistakes that may have come across through doing that research. So what this means is that this is the sample mean, right? This is a sample mean, basically, or sample results, right? But the true value of students that like Cheetos, right? If we go by this, right, it's actually between what? 55 and what? 65%, right? Making room for the 5% both ways, right? Both left and right. So there is a chance that, and this is where the confidence is, right? We can say, okay, well, 90% confident that the true value of students that like Cheetos, right, is between 55 and 65%, right? And the true value of those who hate Cheetos is between what? 35 and what? 45%. This is why sometimes, have you ever watched TV where they say somebody has 55? So let's say Mr. A has 45, and then let's say Miss B has, let's say 40, right? And then they say, maybe let's say John, Mr. John has 15, right? And then they'll tell you that between Mr. A and Miss B is a dead heat, or they are basically statistically equal. And you're like, what? No, that's 45, this is 40. The reason why I say that is if the margin of error is plus minus 5, for example, that means that the true value of Mr. A's answer favorability is between 40 and what? 50, right? How about Miss B? It's between 35 and what? 45. So you can see, in theory, there is an interlap, because if you count 41 to 45, then you count 40 to 45, it's an interlap here. So it's an overlap, basically, between that. So at some point, it is possible that Mr. A and Miss B actually both have what? 45, 45, right? It is possible. So that's why you see them, they'll say, oh, the two of them are at the dead heat. And you're like, no, that's 45, this is 40. It's not a dead heat. He has 5 points more than her, but margin of error is telling us that it is possible that they are basically the same. It's also even possible that Miss B actually has more, right? Because Miss B can be 45 and Mr. A will be what? 40, right? You guys see that? It is possible. And so most times you will see they'll say there's a dead heat. Those people are the dead heat, right? And so always, whenever you look at any polling results, right, always look down to see what the margin of error is, because that will tell you a better story of what you're looking at, right? And that's why sometimes somebody like Miss B could end up winning the elections. And you're like, how is that possible? She was losing by 5 points. No, she wasn't. right? She really wasn't. But there was a chance that she could, right? Because between 35 and 45, any of this number could be her number. For Mr. A, between 40 and 50, any of these numbers could be her number. So there's a huge chance that she could actually have more points than he does. Any questions on this? All right. So we'll continue, and if any questions come up, feel free to ask, right? And so these are the steps to finding correlation, right? I mean, if we're asked to find any question with confidence interval, so steps for correlation, which I should say confidence interval, right? Confidence interval. All right. So one of the things you want to start with is to find your N and find your sample mean. You also want to state your standard deviation. You want to find the value of Z usually given. When I say usually given, is that you can actually look at the graph here and it tells you right here, right? It's given here. And then the next step is you now find your margin of error, because once you find your margin of error, then you can now find the left and the right endpoints, and then you can solve your question. So let's start with some simple examples before we move to something that is more, maybe a little bit more detailed, right? So I'm going to pause sharing and I'm going to go into our Excel, right? So let's see that. All right. Okay, why is it taking such a, let's try that again. All right, can you see my Excel or no?
No.
No? That is weird. Oh. Okay. Let me try again. Let's see this one. Okay, let me pause.